All right, you guys, we're going to work the odds of Chapter 10 review, which is all about circles. And when you look at number 1, first thing I'm going to do is see if it matches any of my pictures on my formula chart. So segment BC is 17, segment DC is 22. So when I look at my formula chart, I'm looking for segment pieces that hit my circle once on one side and hit my circle twice on the other side. So looking at my segment part of my formula chart, this would match the last picture, which tells me to take the little piece and square it and then equal it to the outside times the total length of the other segment. So in my picture, the little piece is 22. So I would want 22 squared equals the outside 17 times the total length. Well, I don't have any values in between A and B, so I'm just going to call this piece, that chunk inside, x, which would make the total of those x plus 17. And then I'm going to square 22, which gives me 484. And when I distribute, 17 times x is 17x. 17 times 17 is 289. You can get x by itself by subtracting 289 from both sides. So 484 minus the 289 leaves me 186 equals 17x. So I'll divide both sides by 17, and that gives me an x, or AB, of about 10.9. Sorry, y'all, this is 484 minus 289 is 195. I'm reading my calculator wrong. So 195, and then divide by 17 would give us 11.5 or 11.4. Yeah, this says round to the nearest tenth, so that would be 11.5. All right, number 3. Number 3 is an identical picture, just flipped upside down. So we would want the little piece, 18 squared, and equal it to the outside times the total, which would be x plus 48. When I distribute this, 18 squared is 324, and x times x is x squared. X times 48 is 48x. Anytime you end up with an equation that has an x squared and an x term, you can't divide or square root because you have both. So you want to move the 324 over to the other side by subtracting, and that would give you x squared plus 48x minus 324. And this looks like our algebra review section. We need to factor that to figure out what the values of x are going to be. So I want two things multiplied together that are going to give me a negative 324, but that add to 48. So that would be 54 and negative 6. So I would say this is x minus, or plus 54 and x minus 6. When those are equal to 0, you want to set each piece equal to 0. So x plus 54 is equal to 0 and solve when x is negative 54. And x minus 6 equals 0 when x is a positive 6. Since x is representing a segment length, it cannot be a negative answer, so my answer has to be x equals 6. Number 5, a circle is the set of all points in a plane that are equidistant from a given point. So that should be G. They're the same distance from the center of the circle, so they're all like 5 units away or something like that. Number 7, you have the arc BAC, which means from B passing A all the way to C is 300 degrees. And we want to find the measure of angle A, which is that little piece right there. If most of the circle is 300, I need to figure out what's left for C to B. Those should total 360. So if I do 360 minus 300, that leaves me a 60 degrees for CB. I can bring that inside to the center of the circle because angle COB, this angle right here, is a central angle, which means it's the same as its arc. And then I could move over. These two next to each other are a linear pair, so if I take 180 and subtract out the 60 that we know, we're going to get 120 for that inside angle next to that. And when I look at this picture, that 120 that I have and the angle I'm looking for are all part of a triangle. More specifically, it's an isosceles triangle because AO and OB are radius of the circle, and so they're going to be the same measure, which means that angle A and angle B are both going to be the same measure. So I could say, okay, they're all supposed to add to 180. I'll take out the 120 I know, and then divide that number evenly by two angles. So angle A should be 30 degrees. All right, number 9, find the measure of PSQ, this angle, if that angle is 3y minus 5 and PRQ is 2y plus 15. When I look at angle S, it forms arc PQ. Angle R also forms that same arc. Remember, it eats the arc that's in between it. So if that's the case, those angles have to be the same. So I would say 3y minus 5 equals 2y plus 15 and solve for y. So minus 2y from both sides. We get y minus 5 equals 15. I'm going to add 5 to both sides, which gives me y equals 20. 20 would be my answer. However, it says we need to find the actual measure of the angle, not just y. So I need to take 3y minus 5 and plug in the value that we know y is, which is 20. So that's 60 minus 5, which is 55 degrees for that angle. Number 11 gives us that arc BCD is 116, DEF is 90, FGH is 138, and HAB, this part right here, is 16. There's a lot of extra information in here. All I'm looking for is this angle, and when I match this to my formula chart, they've given me arc measures and they're asking me to find an angle. So I would match this to this picture right here. Call that number 4. And it wants us to say that the angle is equal to half of the big arc minus the little. And it's always the arcs between your angle. So which arcs my angle eats. So the bigger arc that is between my angle is the 90. The little arc that's between my angle is the 16. So I want my angle to equal half of the big minus the little, so 90 minus 16. 90 minus 16 is 74, so I want half of 74, which is 37 degrees. All right, number 13, RP is 22, RA is 6, and PQ is tangent to the circle at Q. If it's tangent, we know that's a right angle. And I want to find PQ, so PQ is going to be my X. Rule number 1 about circles, if it doesn't fit your formula chart, find the radius. They've given us the radius is 6, RA. I can identify another radius, which is RQ, and also call that 6. And rule number 2 is find your right triangle so you can do Pythagorean theorem. So we have 6 squared plus x squared equals 22 squared. So that is 36 plus x squared equals 484. And when I subtract 36 from both sides, we get x squared equals 448. Oh, didn't even write 448. And when I square root that value, we get an x value of 21.2. All right, looking at number 15. Tells us that RS is a radius of the circle. The fact that they told us that and that ST is tangent is so we can put a right angle where the tangent line hits my circle. This is another Pythagorean theorem, and it's asking if it's tangent. That's what my goal is to find out. Well, if it was a 90-degree angle and if it was tangent, then 4 squared plus 12 squared would equal 13 squared would work. It would make a true statement. 4 squared is 16, 12 squared is 144, and 13 squared is 169. 144 plus 16 is 160, which is not equal to 169. So I would say that ST is not tangent. If it was, I would end up with a true statement like 160 equals 160, but that is not the case there. All right, number 17. Identify the minor congruent arcs. Minor means less than 180. Congruent means they're the same measure. And so I want smaller than 180 degrees angles that are going to that are going to be the exact same. So for example, just off the bat, two angles that I see that are the same are my 55s. So I could say arc CD and arc EF would be a pair. Another pair that I noticed is the same is the 45-degree one. So I could say AG and GF is another pair. And something else that is less than 180 are these two together. That adds up to 90. AF is 90. Another pair that adds to 90 is 65 and 25. So I could also say that AC and AF are going to be the same. There are probably several pairs you could do, but those are just some examples. Number 19, find RS and explain your reasoning. Here's the deal. When you have a chord, QP and RS, that are both the same distance to the center, and I know that because there's tick marks here, they have to be the same length. So I can automatically say that RS is going to be 7. Number 21, given that DAB, angle DAB and DCB are right angles, and DBC, this little piece right there, is 20 degrees. We want to find the measure of arc CAB. So that would be this outer edge. That's our goal. If this is 20 degrees, I can go, it's inscribed, so I can say that the arc that it eats, which is CD, is going to be twice that amount, which would make that 40. If angle C is 90 degrees, that means that DB is a diameter, which means arc DAB is going to be 180 together. So if I want from C to D, but also D all the way around to B, I want 180 plus 40, which gives me 220 degrees for the measure of CAB. Number 23, write an equation and solve for x. When I look at this picture, we have degree symbols, which means we're at the top part of our formula chart, and it looks a lot like picture number 3. which tells me the angle is equal to half of the arcs added together that form x. When I look at my angle is all in line with the 36 and the x, so those are the arcs that I want to use. And remember, the formula is half of, angle equals half of arc plus arc. So I need to plug in the pieces they gave me. The angle in my picture is inside, which is 65. And it's equal to half of one arc plus another, so 36 plus the other, which is x. That 1/2 is throwing me off, so I'm going to multiply both sides by 2 to cancel the 1/2 out. And 65 times 2 is 130. And it's going to be equal to that leftover inside the parentheses part, 36 plus x. So I'm going to solve for x by subtracting 36, which gives me x equals 94. And it's going to have degrees because arcs have degrees on them. All right, let's look at number 25. There it is. All right, looking at this picture, I have degree symbols, and my angle, angle 1, is outside of the circle, so it's either going to match 4, 5, or 6, which is the bottom half of my angles part. And I would say, because it hits, both lines hit my circle twice, I'm going to use this picture, which is 4. And the formula for that is that the angle equals half of big arc minus little. My angle 1 eats this 38 degree arc and the 102. So my angle is going to be the bigger one, 102, minus the little one, 38, and half of that. So I really want half of 64, which is 32 degrees. All right, number 27. When I look at this piece, these don't have degree signs. They're representing segment lengths, not arc lengths. So I would match this picture to this middle segment formula, which tells me that the outside piece times the total length is equal to the outside piece times the total length. And you always want to relate the pieces that are along the same chord together. So I can only talk about C and D on the same side, and I can only talk about A and B on the same side. So on the top one, the outside piece is 9. The total would be 15 plus 9, which is 24. So I want 9 times 24 and equal it to the outside piece of the other one is 8. The total length from tip to end, they're telling me tip to end is going to be a value of x. So it's just 8 times x. It's different than if I put an x there and you want to call that x plus 8 as the total. That bracket tells me it's already the whole length. So 9 times 24 is 216 is equal to 8x. And when I divide both sides by 8, I get an x of 27. All right, number 29, we have segment lengths again. And so I'm looking at the bottom part of my formula chart, and I would call it this first picture, we'll call that number 7. And this one tells me that A times B equals C times D. So again, you can only multiply pieces together that are along the same chord. So only A and B get multiplied together, and only C and D. So looking at our picture, if I continue 20, if I continue drawing on that chord, I'm tracing over the 8. So 20 and 8 get multiplied together, and it gets equal to 10 and the continuation of that chord, which would be 10 times x. So 20 times 8 is 160 equals 10x, and when I divide that by 10, I get an x of 16. Oh, good. We're still recording. My computer fell asleep. Okay. We will do 31 and 33, and then we'll make a new video. All right, so 31, looking at this picture, we want to find the measure of D, then B, then C. So I want to go all the way around. That's my goal to find. So I may have to find individual pieces. The first thing I notice is that since P is drawn with a point, all of these angles inside are central angles, which means the angle is exactly identical to the arc that it forms. So I can automatically move that 58 over. And one thing I also notice is that these are like a bow tie picture. Remember, bow ties are your vertical angles. So even though that angle is 58, I can pull it out to the arc over there and call that 58. Technically, I don't even have to do that, really, because DB, this much of the circle, DB is a diameter, so that much of the circle has to be 180 degrees. So from D to B is 180, and I want to tack on another 58 to that. So I want 180 plus 58. 180 plus 58 comes out to about 238 degrees for that arc. All right, number 33. Find the measure of arc ABD, which is pretty much the majority of the circle, ABD. The only thing they've given us is the 36 degrees, which is this angle right here. And the arc that angle eats is AD. So if I wanted to take this inscribed angle and go out of the circle, I want 36 times 2, which gives me 72 as AD. But 72 is not my answer because they didn't ask me for AD, they asked me for the rest of the circle. So I need to take the total degrees in a circle, 360, and subtract the piece we know of 72, which comes out to 288 degrees because it's an arc.